So I'm going to share on how not to program in Go. These are basically lessons from code reviews. So how many have you all done code reviews as part of your sprint? Right, sometimes people do, sometimes people don't because we are rushing for time. But code reviews are actually quite useful. So you actually see some of these problems that are popping up during code reviews. So I'm just sharing them. So who am I? I'm Donald. I'm currently a senior engineer at Quincus. So Quincus is a logistics software as a service provider. So my background is previously I work on network infrastructure. So I program content delivery networks, software defined networks, and P2P networks. So just a shout out from our company. We are hiring Go developers and data engineers. So if you're interested, you can just go and look at the company website. So why this talk, right? This talk is inspired by Effective Go. So Effective Go provides a reference for idiomatic Go, right? But that is just not enough. Sometimes you need to know what are common Go mistakes and avoiding them. So it makes us also a more effective Go programmer. So what are the common issues that we always see, right? So when we go through the code, some of the common problems we always see is that some developers when they experience an error, they will call panic. So why does this happen, right? Typically, I think in most cases when we started learning Go, the first thing we learn in the hello world example of panic error, we always see that if not equal to new, we just panic. That is the one of the first things we learn when we learn Go, right? So some of these habits will just carry on, but actually in a production environment, right, it's a bad idea. Why? Because the parametric signature, right, of a function, right, in this case, function get weather, right, it does not indicate whether the function will throw a panic or return an error. You simply have no idea. So if a third party throws a panic, there's no way for the programmer to know, right? So the programmer cannot anticipate. He cannot recover from it. So this is why panic is usually a bad practices, especially for production environment. But is there a good use for panic? Yes, sometimes. Like for example, when you are deep in the function call stack, you might not want to propagate an error across the entire stack. So you just want to clean break, then you just panic to just exit the program, right? But that is only for very rare circumstances. But most of the time, you want to handle the error instead of panicking the error. So the next one is making a REST call, right? This is also another common error. Can you see what's wrong with this code? It's not very obvious, right? Everything seems here looks normal. Okay, the error here, right, is basically that there is something wrong with the HTTP client. So when the server API.mycompany.com doesn't respond, this program basically hangs because there is no timeout. So the default HTTP client, the net HTTP package actually has a zero timeout. So the program just hangs, right? So if you use a default client in the production environment, this can, especially in the microservice, this can lead to cascading failures, right? So actual very, very simple solution is to just indicate a timeout when you when you start the HTTP client. It's just a very simple thing, but this is actually very common. This is a very common thing. It actually happens very frequently. We see it during code reviews. So another common issue we always see is logging, right? During logging there are problems, right? And the most common problem is people are not logging useful stuff, right? They are just showing a lot of extra information that might not be useful, right? So you look at this code, right? This code actually shows you a lot of useful things, like when the HTTP method is wrong, it will log with the wrong HTTP method, right? But then you need to ask yourself, if you are the DevOps person, right, receiving the log, how does the message look like? So the very first thing, right, you want to know, right, as a DevOps person, when you receive the log stream, right, is you want to know what is the start of the log stream and when is the end of the log stream. So then you can identify to say that these logs are for a specific process that is encapsulated within these two logs that indicate the start and the end. Then you will know, yes, I am now tracing the log for this particular process. So the very key thing is that the log messages must enable, right, to the must enable the DevOps personnel to troubleshoot the application, right? So when you look at the code, right, there are certain problems here, right? Like if you look at line 9, it just says it logs, it just says it's the wrong method. But then you want to know, when you want to troubleshoot, you want to know what was the actual method being called, right? So you need to log the actual method name into it. So this is things that you need to know to actually to make sure that your logging is useful. So the other one, for example, here is like, for example, when you want to log the get payload, when there is an error, you want to check, you did not log what the actual payload is, right? So people want to see what the request body is. So when they see the request body, then they know, oh, this is wrong. That's why that thing could not work. So you need to log all that in to get the information correct. So this is just some code that shows the logging which is being corrected, so that now the logging is more meaningful. So the next one, right, is a common problem when you are parsing JSON. So we often use the encoding JSON library to parse the JSON, but then there are problems with the encoding JSON, right? So primarily, right, when we encode the JSON in this case, right, the main issue here is default values. So what happen default values? So we know, right, that normally when we go and unmarshal the body, right, the information is actually outside our control. So it is not entirely, so it might not be correct, right? So we might expect the JSON body to contain the field rejectable, but actually the field rejectable might not be there. So what happens when you unmarshal the thing? So if the rejectable field is orbited, right, you will find that the payload value of reject job will also be false, because that is the default value for that struct. So this gives you a problem that sometimes when you unmarshal the JSON, you will not get the correct the JSON you get when you pass the JSON is not the correct one. So you need to be very wary of this. And then the next one, that another one commonly that pop up is what I call awkward hash map. So why is it an awkward hash map? So if you look at, in this case, right, the awkward hash map, right, is basically, you've seen that a lot of people use this shortcut where they make a map of type with a key string and data type interface, so they can put any data in. So it's very convenient. They put in field, right? So why does all these things make things awkward? So the main why it's not awkward is because this kind of code is not maintainable, because the key string values, right, are buried inside the function. So imagine, right, you are being asked to add a new function to process this job map. What will you do, right? You imagine you now the developer, now you have to go and deep dive in the code to find out what the actual key strings are, because you might only know them during runtime, or you might not know them at all, or actually you might know them before runtime, right? So it will be actually very frustrating to work on, right? So I would call such practices, right, the Go code is not maintainable, because it's not easy to discover what are these key string values are. And then, not to mention, there's also a loss of information, right? Specifically the data type, because when you recast a data from one data type to interface, you lose the information. So the best way is to just simply avoid this kind of awkward hash map. Use a struct. Your code will be much more maintainable. So next time when somebody goes through the code, they need to work on the hash map. They now have a struct. We have a well-defined fields. They all know what is it meant for. And then this one, the next issue is the other issue now is slice manipulation, right? So slice is very common in Go. So sometimes small little things we do in Go, right, might actually have a big impact. So like for example, we have two strings, right? Two slices, right? S1 and S2, right? So S2 points to S1, right? So when we update S2, in this case, we actually update S1. So as you can see in between line 9 and line 13, when we update S2, we update S1. So now there's this funny behavior, right? When we actually go and update, now when we want to go and grow the size of S2, right? So we want to add another one. And suddenly we realize this breaks the underlying reference. Now when we update S2, it no longer update S1. So if you look at the code, it looks fine, it compares fine, but actually it breaks the underlying logic, and it's not obvious that the logic breaks. So again, this is another form of common error that also pops up. So this is just me sharing some frequent Go pitfalls that I come across in my work. Y'all have any questions?
How do you suggest we handle JSON unmarshalling issue?
Oh, normally what I do is I avoid binary binary data types. So binary data types are data types that has only two values. So for example, Boolean is either true or false. So instead of true or false, I will just simply use a string instead that says true instead of the actual Boolean value. And then
Oh,
the
I
other
see.
case is when I'm dealing with numbers, I avoid using 0 as the minimum value. Because 0 is another case where you unmarshal and you omit 0 will be the default value. So when you are programming it, you make sure that you know that 0 should not count for a value when you are reading that 0 value. That is one way to avoid this issue if you must insist on using numbers.
So
Important.
go default now value of like numbers and booleans to false and zero, right? So we could deal with those by using pointers. So Kang Ming is asking if we want to write an endpoint and pass the request params and body, is it preferred if we use a struct instead of a map?
No, it's fine using a map. It's fine using a map. A struct is more for like we are passing something from one function to another function. Internally, you can use a map. It's not an issue. You get from internally, you want to use a map within a function is okay, right? The main thing is the map will become extremely unwieldy when you have key more than 5 key strings. So suddenly when you realize that you're dealing a map with 20 or 30 key strings, suddenly you realize it's not possible to remember or keep track all of them mentally in your head. And that's when you prefer to have a struct to deal with it. Then every time you check, then you see, I know this is the correct data type, this is the thing. So it actually reduces your mental load. And also easy for other people to look up in future. Because once you have too many key strings, it's hard to manage.
So Donaldson, just wanna draw a bit on your experience. So like I believe that you came to go from a background of another language, right? So what do you think is the best thing about Go compared to your previous experience with another language?
Previously, I was using a lot of Python and Java, but everyone knows the regular the very complaint with Java is just there's too much boilerplate code. Whereas when I wanted to do networking stuff, I realized Python is just not good enough to deal with low level stuff. I can use Python for orchestrating network devices. I can use Python for orchestrating virtual machines. But when you ask me to use Python for packet processing, right, it's not very it's just not very good at doing their job. And the main thing about Python that irks me, right, is sometimes I get the data type wrong. So when I write in the code, I actually have no idea. This is a big problem, especially when you do a big code base. You really lose track of all the functions really. So I need a way to allow me to quickly check whether the code is at least correct when I'm using the type. So Go is actually very convenient.
Oh, interesting. So that's like a move from a dynamic
Yeah.
language to a
So once you have too many variables, you want to use language features to help you to reduce complexity in managing your code.
I think yeah, a lot of startup when they evolve from a early stage to a more organized and like a larger organization size, they tends to do that as well to put more order in place.